Good day, dear colleagues. My name is Vitalii Tron. Today I would like to present the results on recognition of mineralogical and technological varieties of iron ore on the basis of ultrasonic backscatter spectrograms. Information about the mineralogical varieties of iron ore can be effectively used to improve the quality of its preparation for metallurgical processing. The technologies of mineralogical analysis that exist and are used in practice take a lot of time and require significant labor cost for preparatory operations. Ultrasonic measurements is widely used for the detection, localization, and characterization of materials with important applications in many fields. However, the solution of these problems is associated with great difficulties in relation to inhomogeneous media in which the ultrasonic wave is scattered by the microstructure of the material. Thus, the actual problem is to substantiate the necessary and sufficient set of estimated characteristics of the process of propagation of ultrasound in randomly inhomogeneous media, as well as the development of effective methods for the processing for operational, non-contact, non-destructive mineralogical analysis of iron ore. Measurement method based on the evaluation of the characteristic of backscattered ultrasonic waves in the medium under study are widely used. A promising approach in the implementation of the mineralogical analysis of iron ore is the use of the parameters of the backscattered ultrasonic signal propagating in the studied samples and modern methods of their interpretation and analysis. The problem is the development of method for measuring characteristics, modeling, classification, and recognition of randomly inhomogeneous media. The research presents the results of the development, justification, and approbation of the method for recognizing the main mineralogical and technological varieties of iron ore of the developed deposit based on the spectrograms of the backscattered ultrasonic probing signal using the ANFIS Near Fuzzy classifier. In mineral varieties, individual types of magnetite aggregates are unevenly distributed and have different configuration as it's shown on the slide. When ultrasonic waves propagate in a randomly inhomogeneous medium with the characteristic given in the research, their attenuation occurs due to the absorption and scattering of elastic vibrations of the mineral formations of iron ore. Fluctuations in the number and size of minerals inclusions in a controlled volume of the medium under study affect the parameters of the ultrasonic signal measured by the detector. Let us consider in more detail the scattering of ultrasonic waves on mineral inclusions in iron ore. On the figure on the slide, it is shown the types of ultrasound scattering depending on the ratio of its wavelengths and the size of the scattering structure. Specular scattering, figure A, occurs when an object is much larger than the ultrasound wavelength. The ultrasonic wave can be reflected or refracted through the boundary between the object and its environment. Diffuse scattering on figure B occurs when the structure is much smaller than the ultrasound wavelength, and diffraction scattering, figure C, occurs when the wavelengths and size of the object are comparable. In this case, the incident wave scatters equally in all directions. The scheme of functioning of the system for recognition of mineralogical and technological varieties of iron ore, it is shown on the slide. The functioning algorithm includes the processing of ultrasonic signals and annotations, as well as training of the recognition system. Acoustic characteristics are extracted from the measurement results, and at the training stage, a correspondence is found between them and the characteristic of the iron ore samples indicated in the annotation. The testing chain includes processing test signals as for training, testing the system, and, if necessary, post-processing the output of the system to obtain a representation similar to annotations. Spectrograms are two-dimensional visualization of spectral sequences with the time on the abscissa and frequency on the ordinate. The color intensity of each pixel is related to the amplitude of the corresponding frequency. When ultrasonic waves propagate in a rock, due to their multiple reflection and scattering on mineral formations, a spectral characteristic of the medium in which they propagate is formed. Thus, the spectrogram of a backscattered probing signal is a spatial, in certain area, amplitude frequency characteristic of the medium under study, or its acoustic, structural, textural image. To obtain spectrograms in accordance with the methodology used in the research, a short-time Fourier transform was performed for each window segment of the recorded probing signal. On the figure on the slide, it is shown spectrograms of various mineral varieties of iron ore, and the x-axis represents time in milliseconds and y-axis represents frequency scale in hertz. Pixel intensity represents the amplitude. To implement this procedure, ANFIS adaptive narrow fuzzy inference system is used. The editor of the MATLAB package allows to solve the task of recognizing the main varieties of iron ore of the developed deposit, the vector of parameters of the membership functions, of the terms of the input variables, and the vector of coefficient of linear functions in the conclusions of the rules are formed based on the characteristics of the processed ore and the spectrograms of the backscattered ultrasonic signal. ANFIS, the editor, automatically synthesizes a narrow fuzzy network from the experimental data, which can be considered as one of the varieties of fuzzy inference of the type Takagi-Sugeno. In the process of approbation of the used recognition method, they evaluated adding the number of epochs of learned types and number of functions of occurrences of input fuzzy terms in the ANFIS model for the accuracy of classification. In the process of researching the influence of the types of membership functions of the input fuzzy terms of the ANFIS model, the following constant parameters were adopted. The number of learning epochs was 20. The number of input functions belonging to fuzzy terms was 3. Type of output membership functions was linear, and the type of input membership functions were investigated. The results of the study of the influence of the types of different membership functions of the input fuzzy terms of the model on the classification accuracy and spent time on training are shown on the slide. As you can see, the best result was demonstrated by bell-shaped and two Gaussian functions. The average accuracy of recognition of magnetite, chloride carbonate magnetite, and other varieties of the iron ore with the specific parameters of the model was 93%. Thank you very much for your attention.